the powers of I. And it looked into the pattern that I creates. Would you agree? Okay, and so we learned that I has 4 possible values. It's possible that a power of I is equal to I. It's possible that the power of I is equal to -1, that it's equal to -I, and that it's equal to +1. Okay, those are the only 4 values that a power of I can take. It's going to be one of those 4. And your task is going to be figuring out which of those 4 values your power of I expression is equal to. And I've got a really simple way for you to do it. Okay? What you are going to do is you are going to take your exponent, or your power, and divide it by 4. Okay? If you take your exponent and you divide it by 4, and the result is some number with a decimal of 0.25. Okay, that would be your remainder is 0.25. So if you take your power, divide it by 4, and your answer gives you a decimal of 0.25. Then your power of I is equivalent to I. If you take your exponent and divide it by 4 and get a remainder of 0.5, your power of I is equivalent to -1. If you take your power and you divide it by 4 and you get an answer with a decimal of 0.75, the power of I will be equal to -I. If you take your exponent and you divide it by 4 and you get a whole number answer, meaning there is no remainder, okay? Your answer is an integer. Your power of I is equal to 1. So to simplify your power of I, take the exponent and divide by 4. Based on that result, you know what that power of I should be equal to. Okay? And down here we go through 4 different examples. Okay? So if I have I to the 40th that you're asked to simplify, you want to take the 40 and divide it by 4. That gives you a result of 10. And because there is no remainder, your answer was just 10, that's an integer, I to the 40th would be equal to 1. For I to the 41st, take 41 and divide it by 4. That equals 10.25. Since your answer has a remainder of 0.25, it has a decimal 0.25, you know that I to the 41st is equal to I. For I to the 42nd, take 42 and divide by 4. That gives you 10.5. Because you have a decimal remainder of 0.5, that means I to the 42nd is equal to -1. I to the 43rd, take the 43 and divide by 4, gives you 10.75. You have a decimal remainder of 0.75, which means I to the 43rd is going to equal -I. All right, so for our first example, we are taking -10I to the 6th power, which means I am taking -10 to the 6th power, and I'm taking I to the 6th power. -10 to the 6th power is 1 million. What is I to the 6th equal to? Take your exponent 6, divide it by 4, gives you 1.5. And if your decimal is 1.5, what does I to the 6th equal? -1. So I will replace I to the 6th with -1. And then I will multiply 1 million times -1, which gives me -1 million. For example 2, we are taking 6 times I to the 37th minus 4 times I to the 51st. So I need to, for my step 1, figure out what is I to the 37th simplified. So take 37 and divide it by 4, and what do you get? When you take 37 and divide it by 4, what do you get? 9.25. And if the decimal remainder is 0.25, what is I to the 37th equivalent to? I. Good. So this would be rewritten as 6I. Next, we're going to simplify I to the 51st. So take 51 and divide it by 4. What do you get? 12.75. And if your decimal is 0.75, I to the 51st is equivalent to -I. To simplify here, -4 and -I becomes plus 4I. So this is 6I plus 4I, which gives me 10I as my final answer. Okay, example 3. First off, we already established that I to the 6th was equal to -1 from example 1. Okay, so we're going to go through here, we're going to simplify I to the 6th, I to the 4th, and I to the 2nd. And then we'll look at what we have. So I just said I to the 6th is -1. What was I to the 4th equivalent to? 1, so plus 1. What is I to the 2nd equivalent to? -1. And then we have plus 1. So we're taking -1 plus 1 plus -1 plus 1, which equals? 0. Very good. All right. On example 4, there are 2 ways that I could approach this. I could start by distributing I to the 17th. Or I could start by simplifying I to the 17th. I'm going to simplify. Let's simplify I to the 17th. So take 17 and divide it by 4. What do you get? 4.25. And if you have a decimal remainder of 0.25, that means I to the 17th is equal to I. So I can rewrite this expression as I times 2 plus I. Now I will distribute, which gives me 2I plus I squared. And we know I squared is equal to, so my answer here would be -1 plus 2I. If I want to put my complex number in standard form. Right, the real part followed by the imaginary part. Okay, so I chose to simplify instead of distribute first on number 4. So I'm going to distribute first and then simplify on number 5. So the first thing that I want to do on number 5 is distribute. So I'm distributing I squared times 3, which is 3I squared. And I'm distributing I squared times 4I, which is, anyone? 4I cubed. Very good. Next, I'm distributing -I cubed to -8, which would give me plus 8I to the 3rd. And distribute -I cubed to -2I, which would give me, yes?
2I to the 4th.
Good. Positive 2I to the 4th. Okay, I want you to notice that your middle two terms are both I cubed, right? Agree? Okay, those are like terms and can be combined. So I'm going to go ahead and combine them. I now have 3i squared plus 12i cubed plus 2i to the fourth. Now let's finish simplifying. I squared is equal to, okay, so this becomes negative 3. I to the third is equal to, okay, so this becomes minus 12i. And I to the fourth is equal to 1. So this would just be plus 2. Combine your real parts and you get negative 1 minus 12i. First thing we did here is distribute the 5i and got 45i plus 5i squared, right? And then we said we multiply I to the 12th and I to the 11th, but our exponent rules, when multiplying with exponents, we don't multiply the exponents. What do we do with the exponents? Add them. So this would be plus 10i to the 23rd. Okay, we know I squared is negative 1, so this is 45i minus 5. And then I to the 23rd, if we take 23 and divide it by 4, we get, what? 5.75? And if it's 0.75, then I to the 23rd is negative I. So this would be minus 10i. So I would combine 45i minus 10i for a final answer of negative 5 plus 35